Hello. So, as promised, this is the review on the most challenging problems from the midterm exam. There were two questions in particular. Every question, there were 14 questions on the midterm exam. 12 out of the 14, everybody, the average score was 90% or more of the possible points. So those questions, although they presented individual problems, collectively you guys did very well. And so I'm happy to discuss those problems. We can talk about them individually, but in purposes of addressing killing the most birds with a single stone, I'm addressing the two problems that actually had scores that were significantly lower. I think actually only the average score might have been 70-something percent, 75% or so on these two questions. And those are question 11 and question 13 on the exam. So question number 11 on the exam, first, was about a challenging question, apparently, on comparative advantage. And this was the basic setup. So we had Jacques and Gus, and so you were told Jacques and Gus, of course, the two mice from Cinderella, but I wanted to think of two products, thought of cheese and wine, thought French, thought Cinderella, which is actually based on a different named French fairy tale. It'll come to me because my son just read it. But anyway, so Jacques and Gus are neighbors who each work producing wine and cheese. And you were given here a table that for Jacques and Gus gave the hours required per bottle of wine and the hours required per pound of cheese. Now that was the first thing I think important to recognize, is this is the amount of inputs required per output. Hours required per bottle of wine. Hours required per pound of cheese. For example, it wasn't the number of bottles of wine produced per hour or the number of pounds of cheese per hour, which would be the output for a given input. This is the inputs required for a given output. And we talked about it could be presented in either way. It's actually important that it's presented in this way, even though I've heard others say, it's easier for me to understand it if it's presented one way versus the other. So first, you had to make sure you understood that you're presenting, inputs, not outputs. But second, remember when we're going to get to this idea of the definition of advantage, it's defined in terms of the inputs required per output, right? And so it's actually important that the data be presented this way. If it was presented the other way, we would have to convert it at some point anyway. All right, so the first question you were asked was, what is each neighbor's opportunity cost of producing wine and of producing cheese? In other words, every time that Jacques produces wine, what is he giving up? That's the definition of opportunity cost. In other words, in this case, the idea is how much cheese could Jacques have produced instead of you producing wine, and vice versa, and the same for Gus. So you're asked to, so let me just here's a table, when you were given a table similar to this, for each of them what the opportunity cost was per bottle of wine and opportunity cost per pound of cheese. Well, I'll just pick, for simplicity actually here, the upper right cell of that bottom table, which is the opportunity cost per pound of cheese for Jacques. Okay? Now the first thing is, to calculate Jacques' opportunity costs, we calculate them completely separately from Gus. We don't even need to look at Gus at all for this particular question. For the next ones you do, but we can focus on Jacques alone. But in particular, what we have to do opportunity costs, we have to compare the inputs. How much input it takes per bottle of wine, how much input it takes per pound of cheese. So 1 hour per bottle of wine, 3 hours per pound of cheese. So the opportunity cost per pound of cheese, right? The idea is in order to produce a pound of cheese, what's the opportunity cost? Well, what's the input cost, first of all? The input cost is 3 hours. So in order to produce a pound of cheese, Jacques will devote 3 hours of his time. Now, during those 3 hours, what's the cost of those 3 hours? In other words, what could he have been doing during those 3 hours? Well, the only other thing he does is produce wine, right? So in those 3 hours that he uses to produce a pound of cheese, the opportunity cost per pound of cheese, in those 3 hours, he could have produced how much wine? Well, each bottle of wine takes 1 hour. So if he had, in 3 hours, he could have produced 3 bottles of wine. Therefore, the opportunity cost per pound of cheese is 3 bottles of wine for Jacques. Similarly, then we can then look at what about the opportunity cost per bottle of wine for Jacques, right? Well, it takes Jacques 1 hour to produce a bottle of wine. In that time, if he was instead producing cheese, how much cheese would he produce? Well, it takes him 3 hours produce a pound of cheese. So in the 1 hour that he was using to produce a bottle of wine, the opportunity cost in terms of foregone cheese production is 1/3 pound of cheese, right? Because it would, in that 1 hour that he takes to produce a bottle of wine, he could have produced 1/3 pound of cheese. It would have taken 3 hours to produce a full pound of cheese. But during that 1 hour he produced a bottle of wine, what's the opportunity cost? Now, we can then look at Gus. Now, let's first look at Gus's opportunity cost per pound of cheese, right? And in here, again, for Gus, we can focus for Gus's opportunity cost. We can completely ignore Jacques' data. We only have to look at Gus. We have to compare the inputs that Gus requires to produce a bottle of wine and the inputs Gus requires to produce a pound of cheese. Well, if you want to focus on the opportunity cost per pound of cheese, the idea is, well, first, what is the input cost? Well, the input cost is 4 hours. In this case, the only inputs here, by the way, are time, right? So it takes 4 hours, right? Well, remember, the definition of opportunity cost is, what else could you have done with that money, that time, those resources, whatever it is? Well, in this case, it's just hours, so just time. So what could Gus have done per pound of cheese? The opportunity cost per pound of cheese, well, a pound of cheese costs 4 hours. Well, what is the opportunity cost of those 4 hours? In other words, what else could Gus have done in those 4 hours? Well, the answer is, if he had worked on producing wine for 4 hours, he could produce 2 bottles of wine, because it only takes him 2 hours per bottle of wine. If he spends 4 hours producing cheese, he could have produced 2 bottles of wine during that time. So the opportunity cost per pound of cheese for Gus is 2 bottles of wine. For every pound of cheese that Gus produces, he is giving up time that could have been used to produce 2 bottles of wine. We can then also look at the inverse now and look at the opportunity cost per bottle of wine for Gus. Well, for every bottle of wine Gus produces, requires him 2 hours, right? If instead, what's the cost of those 2 hours? What is the opportunity cost? What's the next best use of those 2 hours? Well, if he used those 2 hours to produce cheese, right? How much cheese would he have produced in those 2 hours? Well, he would have produced half a pound. It takes him 4 hours to produce a full pound of cheese. So in those 2 hours, he would have produced half a pound of cheese. So for every time he produces a bottle of wine, which takes him 2 hours, he is giving up the opportunity, hence opportunity cost, to produce a half a pound of cheese. And so these are the opportunity costs for Jacques and Gus. Now, many of you, had it the other way around, right? First of all, notice that, of course, that as we said before, these numbers will always be inverses. Most of you got that. I don't see too many problems with that. If the opportunity cost per pound of cheese is 3 bottles of wine, the opportunity cost per bottle of wine has to be 1/3 pound of cheese. The 1/3 is 1/3. Obviously, 1/2 is 1/2, and vice versa. 1/1/3 is 3. 1/1/2 is 2. They're inverses of each other, right? Several of you on the first part here had it reversed. You had 3 pounds of cheese or 2 bottles of wine, or 2 pounds of cheese and a half bottle of wine. That particular part of the question was worth 4 points. I didn't take off full credit if you had the right numbers, but you had them reversed. I took off half credit, so you got 2 points. But that said, if you had these reversed, you were going to be in trouble for the rest of the question. The rest of the question you were probably going to get wrong, right? And so a number of you made that mistake, that difference, right? And that sort of, resulted in, the rest of you scoring poorly on the rest of the question. Now, that said, one check that I would recommend is to be sure, because it's very easy to get them reversed. So if we ever do a problem like this in the future, not going to be required on the final exam or anything, but if you did, you'd say, well, wait a minute. Which should be more expensive, right? This is the cost for Jacques. Well, look, which should be more expensive for Jacques? Well, what takes him longer? Well, it takes him longer to produce cheese than wine. So cheese should have the higher number. So that's a double check to make sure that the bigger number, 3, is here under cheese, and the small number is under wine. And the same for Gus, right? The item which requires a greater input also is going to therefore have a greater cost, and in particular, a greater opportunity cost. So that's a good way to check it. And again, I know a lot of you got stuck right there. You did the right math, but you sort of had it reversed. All right, so let's take so now let's take those 2 tables and repeat them. So this is the hours required per bottle of wine on top. Here, the first table we showed, that's a table you're given in the question. And the table we just created, which is the opportunity cost per bottle of wine, the opportunity cost per pound of cheese for Jacques and Gus, right? And now the next question asks you, which neighbor has the absolute advantage in producing each good? Right? Well, for absolute advantage, right, remember, we have two definitions of advantage, and they have to do with how much it costs you to produce the output, right? For absolute advantage, we measure cost in terms of inputs. Who requires fewer inputs? So, the comparison we're making here is in the top table, right? This is the input. Hours required per bottle of wine, hours required per pound of cheese. These are the inputs that each of them requires to produce that output. And the absolute advantage is going to be whoever requires fewer inputs. Well, for wine, Jacques only requires 1 hour, Gus requires 2. So Jacques is going to have the absolute advantage. Right? Now for cheese, right? Jacques requires 3 hours, Gus requires 4 hours. So again, Jacques is going to have the absolute advantage in producing both wine and cheese, or either. In both areas, Jacques is more efficient than Gus. Right? All right, and so that's going to be the notion of absolute advantage. Now the notion of comparative advantage, right? Now the idea is we're measuring, again, who requires fewer inputs, but inputs are defined in this term in terms of opportunity cost. Not the actual inputs, but who can produce it at a lower cost in terms of the opportunity cost, what they're giving up. Right? And so now we compare the opportunity costs. And before, for absolute advantage, we compared who had the lower input costs. Here we're doing who has lower opportunity cost, right? And for wine, again, Jacques, every time that Jacques produces a bottle of wine, he gives up the opportunity to produce 1/3 pound of cheese. Gus gives up the opportunity to produce 1/2 pound of cheese, right? And so Jacques has the comparative advantage. 1/3 is less than 1/2, right? In terms of cheese, however, right, for every pound of cheese that Jacques produces, he's giving up the opportunity to produce 3 bottles of wine, whereas Gus is giving up the opportunity to produce 2 bottles of wine. So Gus is giving up less. Remember the principle number, 3 of, the price of something is what you give up, in order to get it, right? Who's giving up less? Well, Gus gives up less to produce a pound of cheese. Therefore, Gus has a comparative advantage. Now, I'll notice that, again, we've done comparisons in 3 ways now. The first thing we asked was to calculate opportunity cost. And remember when we did opportunity cost, we were comparing simply comparing for Jacques, for example, 1 hour versus 3 hours. The comparison was within an individual, the relative input costs, right? Comparing 1 to 3. And for Gus, comparing 2 and 4. That gave us opportunity cost. That was the first comparison we did. Then for absolute advantage, we're doing a different comparison. We're not comparing, for absolute advantage, you do not compare, right, the 1 hour here for Jacques to the 3 hours here for Jacques for cheese. We are only comparing, the numbers over here do not matter at all. For absolute advantage, all that matters is comparing who requires fewer hours, right, for each good. That's how you calculate absolute advantage. So again, first comparison to do opportunity cost was comparing the inputs, different inputs required for a given individual, just focusing on Jacques, then just focusing on Gus. Now, right, for absolute advantage, we can ignore, the other product and just say who requires fewer inputs, right? And then now the third comparison for comparative advantage is we're comparing the opportunity cost, right? Again, to figure out who has the comparative advantage in wine, we can actually ignore this data over here on the right about cheese and just say who's got the lower opportunity cost. To do the opportunity cost, or who has the comparative advantage in cheese, we can ignore this information about wine over here and just see who has the lower opportunity cost for cheese, right? And that's going to be the comparative advantage. Now that said, remember, the opportunity cost was actually calculated by comparing the different number of hours required for an individual, right? And so to get to comparative advantage, you actually are doing a 2-step comparison. You first calculate opportunity cost by comparing, for example, what requires Jacques to produce one good versus the other, and Gus to produce one good versus the other. And then once you're doing that comparison within the individual, right, but across products, you now do a comparison across individuals, but within product. Restrict your focus to one product and who has the lower opportunity cost. So comparative advantage absolute advantage is a 1-step comparison. Comparative advantage is a 2-step comparison, right? And again, because of that, the way it works, right, it's even though you can calculate who has the comparative advantage in wine, you can ignore what's going on over here in the opportunity cost for cheese. Because of that sort of 2-step process, the way it works, it's always going to be the case that no individual can have a comparative advantage in both goods, even though they could have a comparative advantage or absolute advantage, in both goods, as Jacques does. All right. So you were next asked, so If Jacques and Gus decide to specialize according to their comparative advantage, which neighbor will produce each good? Well, if they specialize in their comparative advantage, Jacques has a comparative advantage, as we see here, in wine. Gus has a comparative advantage in producing cheese, right? Therefore, Jacques will specialize in wine. Gus will specialize in production of cheese. Right? And then you were asked, okay, well, if such specialization happens, how much of each good will Jacques and Gus together produce after each working for 60 hours? Okay, well, so if Jacques, in other words, if Jacques spends 60 hours producing wine, Gus spends 60 hours producing cheese, how much of each do we get? Well, let's focus first on wine and Jacques. So Jacques produces wine and focuses all his 60 hours on wine. Well, we can see up here, Jacques it requires him 1 hour to produce a bottle of wine. In other words, for each hour, he produces 1 bottle of wine. Right? So therefore, in 60 hours, he's going to produce 60 bottles of wine. So the output, the total output of wine, if under the specialization, will be 60 bottles. Now, what about cheese? So now here, meanwhile, Gus is specializing in cheese, right? Well, how long does it take Gus to produce cheese? Well, it takes him 4 hours per pound of cheese. So for 60 hours, and 60 hours divided by 4, he takes 4 hours per pound of cheese, he's going to produce 15 pounds of cheese in those 60 hours. And that's going to be the combined output. 60 bottles of wine and 15 pounds of cheese will be the combined output if they each specialize in their area of comparative advantage. Now, you were then asked, you said, well, okay, now we're asked about prices in terms of exchange, right? And this is a little more advanced than, if I had, and I originally made this particular part of it extra credit, but then it turns out I added up the points and it was 110 points for the whole exam, and I said, well, I could reduce it so it's 100 points of the exam, or I could just say, leave it 110, and then there's 10 points of extra credit wherever it is. So this was, originally going to be extra credit anyway, but the total was, instead of just having these 4 points of extra credit, now I actually give you 10 additional extra points, then 10 points of extra credit on the exam, plus of course the public good game and the practice questions, etc. But so the whole point of that is saying this is not easy. This next part, not that the earlier part was necessarily easy, but this part I knew might be difficult. But before specializing, of course, Jacques and Gus would presumably agree upon mutually beneficial terms of trade, right? We know that specialization, we're going to see sort of in hindsight, it makes sense that specialization is a good thing, but, right, I'm not going to, if I'm Jacques, I'm not going to produce only wine, hoping to trade cheese with you later, Gus, right? And then you don't give me a raw deal, or vice versa, right? We each got to sort of say, wait a minute, I'll produce wine, you produce cheese, or vice versa, and then we're going to trade according to these terms, right? Well, so then I said, well, which of the trade arrangements would potentially be beneficial to each party? I gave you 4 candidates. Would they will exchange 20 wine for 5 cheese, 12 wine for 5 cheese, 6 wine for 5 cheese, or 5 bottles of wine for 5 pounds of cheese, right? So again, I didn't write the units here, but 20 bottles of wine for 5 pounds of cheese, down to 5, a 1-to-1 sort of comparison. Now, understand what's going on here. The 20 wine is what Jacques is giving up, of course, and the cheese is what Gus is giving up, because Gus is producing all the cheese, right? And to make it somewhat easier, you'll notice that I did it all in terms of 5 cheese per 5 cheese, right? Now, several people got this question wrong, but gave the answer. They selected A, 20 wine for 5 cheese. Let's focus on that. Now, I presume, and sort of I have asked questions to people that told me that they figured, yeah, that seems right, because look, we got 60 bottles of wine and 15 pounds of cheese. That's the same ratio as 20 wine for 5 cheese, right? So, but basically what you're saying is, look, here's what we got. Let's split it equally. That's what you're saying when you chose answer A, right? And that might seem right, except why should Jacques split it equally with Gus? Jacques is better at everything than Gus. If they were on their own, who would be better off? Jacques. Because Jacques only takes 1 hour per bottle of wine, where Gus takes 2. Jacques only takes 3 hours per pound of cheese, whereas Gus takes 4. So understand, just before we even do the math, right, that deciding to split the total pie, the total output equally, is not going to happen, necessarily, is not going to be necessarily agreeable to Jacques, and we'll see why. But understand intuitively why it isn't, is because Jacques needs Gus less than Gus needs Jacques. Remember, trade can make everyone better off. It doesn't say that trade can make everyone better off by the same amount, right? Is the more productive you are, the more you can, have better terms of trade, right? Better terms of trade you can get. There's no question about that. And to see why, now let's get more specific. So now understand why on the face of it why this won't necessarily work, because it's basically saying, we're each going to work, I'm going to be more productive, and then we're going to split it equally. Well, no. If I'm more productive, I want more of it. Right? But why mathematically won't this work? Well, think about this. Suppose we had this deal. We tried to say, look, Gus and Jacques did the math, and they figured out the production, and then Gus said, let's split it equally. Right? At the end, I'll give you, 5 cheese for 20 wine, and then we'll, how much I give, but on these terms, this ratio, right? Well, in that case, Jacques would say, wait a minute. You want me to give up 20, I'm producing 6 bottles of wine. You want me to give up 20 of my wine for 5 pounds of cheese. Well, I don't need you for that. Suppose I wanted those 5 pounds of cheese, and I didn't want to trade with you. Well, all I would have had to do was to get 5 pounds of cheese, right? Instead of producing 60 bottles of wine, to get 5 pounds of cheese. Look, it takes me 3 hours per pound of cheese. So I would have had to use 15 hours of my time to produce those 5 pounds of cheese myself. So if I use 15 hours of my time to produce those 5 pounds of cheese that you're offering me, I would have produced how much wine? Well, I would have produced 45 bottles of wine, because I would have had to take 15 hours away from wine. So I could have gotten those 5 pounds of cheese myself, right, by only giving up 15 bottles of wine. And you want 20 bottles of wine from me. No deal. Right? So think about that conversation, right? The idea is that Gus says, hey, I'll give you 5 pounds of cheese for 20 bottles of wine. Jacques would say, no, because I'll just produce those 5 pounds of cheese myself, and I'll only give up 15 bottles of wine. I'm not going to give you 20 bottles of wine for your cheese when I can do it myself for only 15 bottles of wine. Right? So that's why answer A is not going to work. Right? And we're getting an inclination about now what answers might work. Right? So let's take that away and reshape it. Let's remember our opportunity cost per bottle of wine. Right? Let me just put this up here. Right? For Jacques, the opportunity cost per bottle of wine is 1/3 pound of cheese. And for Gus, it's 1/2 pound of cheese. Opportunity cost per pound of cheese for Jacques is 3 bottles of wine, and for Gus is 2 bottles of wine. Well, we already sort of got the idea, remember, that it can't be, the reason the 20 wine for 5 cheese didn't work is because it was too expensive for Jacques. Jacques would rather do it on his own, right, without Gus. Right? But it can't be too little, because you don't want Gus to want to go on his own and produce his own wine, for example. Right? Well, what determines what the right price is, if you will, for bottles of wine? Well, the answer is, you may remember this, it's got to lie between their 2 opportunity costs to make it worthwhile. Otherwise, if it's above my opportunity cost, if I'm paying above my opportunity cost for something, I'd rather do it on my own. Right? If I'm receiving below my opportunity cost, I'm a seller for something, I would rather not sell it, rather use it myself. So the point is that these are the person who's buying, if you will, is only willing to pay no more than the opportunity cost. The person who's selling is not willing to sell for below their opportunity cost. And so these are the bounds on the prices. Right? So let's focus on this right side, for example. By the way, they're inverses, so you could actually choose either one to figure out how the ratios work. But for easy math, rather than working with fractions, let's work with these numbers over here. So we know that Jacques' opportunity cost per pound of cheese is 3 bottles of wine, and Gus is 2 bottles of wine. So the price, the quote-unquote price of cheese, has to be between 3 bottles of wine and 2 bottles of wine. So we can write that, right? 2 wine, the price of cheese has got to be greater than 2 wine and less than 3 wine. So 2 wine is less than or equal to the price of 1 cheese, less than or equal to 3 wine. That's sort of the bounds on the price of cheese. But down here, notice that all of our things are in terms of 5 pounds of cheese. So we could also just multiply everything by 5. And so what we've also said then is, okay, what we're really saying is the price of cheese for 5 cheese, right? The only prices that work for both parties are something between 10 bottles of wine and 15 bottles of wine, right? As we sort of gave the example of the reason that the A was not a correct answer. Remember that Jacques was not willing to give up more than 15 bottles of wine for 5 pounds of cheese. But similarly, Gus would not be willing to sell 5 pounds of cheese for less than 10 bottles of wine. Otherwise, he could make himself better off by making his own wine. Right? So what that means is that, again, the price 5 cheese has to be exchanged for somewhere between 10 bottles of wine and 15 bottles of wine. So if you look at answers C and D over here, right, those cannot be valid answers because, again, it's 6 bottles of wine for 5 cheese, 5 bottles. That's not. Whereas answer A was, that was, asking Jacques to give up too much wine for cheese. Here, C and D, Gus is getting too little wine in exchange for his cheese. Right? So he's not willing. Gus wouldn't agree to C and D. Jacques would not agree to A, right? Which leaves B, And of course, B is 12 bottles of wine for 5 Gs. That is bigger than 10 bottles of wine, less than 15 bottles of wine. And that is the only, obviously 13 bottles of wine, 11 bottles of wine, right? Somewhere in there, right? There could be other options. What exactly works in the exact terms could depend on, the utility functions, how much you like cheese versus wine. But the point is, the question very carefully asks, which of these trade agents could potentially be beneficial to each party? And I didn't even ask you what was beneficial. But we know for a fact it cannot be A, it cannot be C, it cannot be D, right? And the idea is that that the only potentially beneficial trade is B, 12 wine for 5 cheese. All right? Again, complicated question, difficult question, and obviously I took a fair amount of time to explain it. If I was presenting this in class, I wouldn't take all this time, but and I apologize to you for. Hopefully, if you're watching this on video and you want to go through it quickly, you can just accelerate. But then again, I already talk fast. But I'm not trying to take up too much time. That's why I'm recording this video and not taking class time. But given that I'm not taking class time, I wanted to be very thorough. And not only give you the right answer, but also, of course, explain why. Make sure you understand this, because this is my last chance to teach you gains and trades. My last chance to teach you microeconomics. We've already moved on to micro. All right, and so then the other question in the exam, the only other question in the exam that was a significant challenge to a significant number of students, such that the average score was below 90%, was question number 13. And this is a question about externalities. In particular, a negative externality and corrective policies thereof. Right? So here's the scenario as I set it up. So the question said, consumption of gasoline imposes several external costs in society, including pollution as well as traffic congestion and accidents. Remember, external costs are not the cost of production, which would be the private cost of producing gasoline, but the additional costs to those who aren't even involved. You could consume no gas whatsoever, but you're still going to be subject to pollution, traffic congestion, and accidents, right? These are the costs on the people who aren't buying or selling gasoline necessarily, right? But it's also, of course, the cost of the people who are buying gasoline. My consumption of gasoline has external costs on you, even though you are also a consumer of your own gasoline, right? So suppose economic analysis estimated the total combined impact of these external costs to be $30 per barrel of gasoline. That's the total external cost per barrel. For every barrel of gasoline that is consumed, produced, right, the total combined external cost, not the cost of production, but the external cost to those outside the transaction is $30 per barrel. And so then I said, I'll give you a graph that said, look, this graph depicts the demand for gasoline. Right? Remember, what is demand? The demand curve reflects the marginal private value at each consumption level. What the value of that one more gallon of gasoline is, the marginal, at the margin, that last gallon of gasoline that's consumed, what is the value of that last gallon of gasoline, and or barrel, I guess actually we're doing in this case. And the supply of gasoline, the supply curve reflects the marginal private cost, the cost to produce that marginal barrel, right? So then I gave you this diagram here, right? There's supply curve, demand curve, the quantity of millions of barrels, the price per barrel, right? Again, just to reiterate what we're saying here, for example, let me take this 5 millionth barrel here, which has at the demand curve is at $80. What that's saying is that that the 5 millionth barrel that is consumed is worth exactly $80, right? And that was the marginal value, right? The next barrel, the 5,000,001 barrel, is now worth $80. It's worth less than $80, right? And so we see, again, of course, decreasing marginal value, but the idea is that's what the demand curve reflects, and this reflects, more importantly, the private cost. It's the cost of producing, right? Here, for example, at 9 billion barrel, the cost of producing that 9 millionth barrel was $70. The total private opportunity cost, right? The cost of producing the 3 millionth barrel was only $40, but the cost of producing the 9 millionth barrel was $70. So that is the private supply. The supply curve reflects the private cost in that way. That's going way back to chapter 4 or whatever. All right. So then the first thing you were asked to do was to plot the social cost curve, right? And remember, the social cost curve is the social, meaning society, the total cost of society, which includes the private cost, which would be this, the reflected by the supply curve, the private cost of producing that barrel of oil, plus the external cost, right, of the pollution, the congestion, the traffic, the externality, right, the externality created from that. And to plot this, what we know is this is, like I said, the cost of that 9 millionth barrel. Right. Let me take, for example, here. Let's start actually at this 3 millionth barrel. The cost to produce that 3 millionth barrel, right, was $40. Right. That was the private cost. What we're saying is that on top of that, there's external costs of the production and consumption of that barrel of gasoline, right? On top of the $40 production cost. Right? But so we have to basically add $30. We have to add $30 to this private cost, and that will give us a social cost curve. Well, one thing easy to do is find the easy sort of quantities, to calculate. So here's at 3 million, we got a cost of $40. I'm like plotting out the points where it's easy to graph, right? So here's one way you could have done it, right? Because some people drew the social cost curve and they drew it, in the right direction, but they drew it too high or too low or whatever. Well, but the idea here is you take at every one of these, at every point along the supply curve, which reflects the private cost, we're going to add $30, right? That's the external cost. And so just at these particular points here, let me just show you, if $30 higher, the actual total cost, in other words, the private cost plus external cost, the social cost, is going to be $30 higher per barrel, right? And if we sort of connect those points, that is your social cost curve. That is how you draw your social cost curve. The cost is $30 higher. Now, some people, right, just as I mentioned, they would just draw it higher and they didn't really know, let's say, where to draw it, right? And that would cause a problem with subsequent questions. But another thing that was common was people said, wait a minute, so here, right now the market price is $60. So where would the market price be $30 higher? And so they moved up the demand curve, right, to, for example, here at $90, where the price on the demand curve is $30 higher than the equilibrium price with, the market price. That is, as you can sort of hopefully begin to intuit, the wrong approach, because in fact, we could completely delete the demand curve. The demand curve is irrelevant to this question. You could draw the social cost curve without knowing anything about the demand curve, right? We're not talking about what the market price isn't going to be $30 higher, but we're saying the cost, the actual total social cost per barrel is $30 higher. So that's going to be, the social cost curve is going to be a curve parallel in the supply curve, right? But simply $30 higher at every quantity level. So that is how you draw your social cost curve. Right? All right. And again, these questions are all cumulative. If you got it wrong, the first part wrong, you might have had a lot of trouble on some of the later parts. But once you got the social cost curve, then the next question that you were asked was about the deadweight. Actually, I'm sorry. The next question was I asked you first, what is the market quantity without any government, any corrective action, right? And we see here the market, right, is going to be, the quantity is going to reflect where the private cost and private value, in other words, supply intersects demand, right? So we're going to have a market quantity of 7 million barrels of oil, of gasoline, I guess, or I'm not sure. I think it's gasoline, but then the idea is, then I said, well, what is the optimal, the socially optimal? Well, the socially optimal quantity is going to be where the social cost equals the social value. But in this case, by the way, social means total society. We really mean social value, but we're not suggesting there's some additional value that the private value of the individual consumer reflects all of the value. When I buy and consume gasoline, I don't benefit, significantly, certainly other people, with my use of gasoline. The fact that I used gasoline didn't really benefit others, but the fact that I used gasoline did hurt others. You can put the cost on others, right? But we find where this, for a negative externality, we find where the social cost intersects the private value or the demand curve, right? Remember, for a positive externality, we would have additional value, so it would be where the social value intersects the private cost. But, getting back to our negative externality, the more common scenario we think about, we find where the social cost curve intersects the demand curve, right? And that is at a quantity of 5 million barrels. So that is the socially optimal amount. So we're overproducing. We're producing excess. You produce too much of things that have negative externality. So we have excess production of or gasoline in this case, because of a negative externality. Then you're asked, okay, so we produce too much, right? What is the cost of that overproduction, right? In particular, what is the deadweight loss, right? What is the inefficiency, right? What is the fact? Remember, the efficient outcome maximizes total surplus, right? Total surplus being, not just producer and consumer surplus now, right? Because it's not just the producers and consumers who care; it's the social surplus, everybody, right? Those who are being hurt by the pollution and the traffic and the congestion. And the accidents. So we're trying to figure out the total inefficiency because of the negative externality, and in other words, what's the total efficiency because the market quantity is greater than the optimal quantity. right? So we've got these 2 million extra barrels of oil that are inefficiently produced. We know that we shouldn't produce that many, that 5 million is the optimal outcome, which means every barrel that's produced, over 5 million barrels, reduces total surplus, right? Which now includes bystanders, right? The external parties. So we're making society worse off every barrel greater than 5 that's produced. Well, how do we measure and represent that? From these inefficient transactions. We're going to focus on these transactions from 5 million barrels to 7 million barrels. Right? Is there some benefit to those? Yeah, there's some benefit to those. Those who are buying the gas obviously want to buy the gas. Those who sell it want to sell it, so they're benefiting, right? But there's also this external cost, of $30 per barrel. And so, how do we figure out what the net sort of effect on total surplus is? Which is, again, because it's inefficient, it's going to be negative, right? And where is the deadweight loss, right? Now, sometimes when we talked about like taxation and deadweight loss in that case. Right? Remember, the deadweight loss was a result from transactions that did not occur that would have produced surplus. Right? When you tax something, right, we get a lower market quantity. The same thing with if you put price ceilings and price floors that are binding. You have the optimum in those cases is actually above what you actually get from the market with the tax or with the price ceiling. And so therefore, the idea is there are efficient transactions that don't take place. In this case of a negative externality, the deadweight loss results not from transactions that we would like to have take place that don't, but the other way around, transactions that take place that we wish didn't. Right? These inefficient transactions, they do take place and they subtract from overall surplus. So how do we measure that? That's the question. So focusing on those transactions, again, between the 5 million barrels and 7 million barrels. The first thing we want to think about is, look, there is a benefit to those, right? It's not that these are all bad for everybody, right? In particular, I'm sorry. Before I get to that, what is the cost of those? Why are these inefficient? Why are these bad? Well, they're bad because they impose an external cost. Well, how much of an external cost, right? Well, remember, each barrel imposes an external cost of $30. The total external cost for these transactions is going to be, $30 for each transaction, right? Well, how many of them are there? Well, there's 7 minus 5 for all of these transactions for 2 million barrels. The total external cost is going to be 2 million times 30, right? Or 60 million is going to be the total external cost, right? Because the idea is that this vertical distance here, between these two lines is the external cost per unit, and every transaction between 5 and 7. Right, is creating an external cost of 30 for each barrel, right? And so this area there represents, right, it's a parallelogram, but if you could draw it as a rectangle, you would get, in other words, you could sort of see the area of this parallelogram is the same as the area of a rectangle with height, of $30 external cost and width, or of 2 million, right? But the idea is that represents the external cost, right? Up here is this social cost. Here is the private cost. So the difference is the external cost, and for all these transactions. So that pink, I guess, area represents the total external cost from these inefficient transactions. Now, as I sort of said out of sequence, these transactions aren't all bad, right? The reason they take place in the market, without intervention is because some people benefit. Right? Who benefits? Well, the buyers and sellers. And how much they benefit? Well, what's the private surplus, right? In other words, the surplus that goes to the buyer, the consumer surplus, the producer surplus, particularly involved in the transaction. Well, that we draw like we normally do. That is the producer surplus plus consumer surplus, the total private surplus from those transactions, right? And when you don't have an externality, back in chapter 4, or actually 7, I guess, was about efficiency, right? That was the only surplus that mattered, right? Nobody else was affected. The buyer is affected, the supplier is affected, but nobody else was hurt, right? When I buy an apple. But when I buy gas and consume gas, somebody else is hurt, right? So the point is that these transactions between 5 million barrels and 7 million barrels, why do they take place in the market? Because they benefit the people who make those decisions. Who makes those decisions? The buyers and suppliers. And so this is the total surplus of those transactions, the total private surplus that the buyers and suppliers get from those 2 million barrels of additional barrels of gasoline being sold, right? But so you have, again, this external cost, but this private benefit, or total private surplus from those transactions. Well, so you've got a cost, you've got a benefit. Obviously, these are inefficient, so the cost exceeds the benefit. What's left over, right? Well, what's left over, the inefficiency, is that area there. That is sort of this blue area there. If you think about this, right, go back to the pink trapezoid, right? What part of this pink trapezoid is left over after you take away this private surplus, private benefit? Well, the answer is that part there. Right? That's the deadweight loss. Due to the, that is the deadweight loss. That is the external cost that is not offset by a private benefit or private surplus. Right? In other words, so it is the external cost minus the private surplus, or it's the deadweight loss is equal to that external cost we graphed before minus that private surplus, which is that area. This is the positive. That is the deadweight loss. Another way to think about it, besides doing this sort of combination of geometric shapes, is that really what we're saying is, think about it, like you can do it in one step by saying, look, this red line, this social cost curve, that reflects the cost of the total cost of each barrel of gasoline, right? And the demand curve reflects the total value. So for each transaction, the surplus that's generated from the transaction is the distance between the value minus cost. This vertical distance here, right? So when the 2 millionth barrel of oil is barrel of gas, I guess, and is the way I defined it, is produced and consumed. Well, actually, that's not the 2 million. Let's do 3 million because that's easy graphically. So the 3 millionth barrel, right? It generates a value of $100 for that barrel, and a total cost, external plus private cost, of $7 per barrel. So there's $30 of surplus generated by that transaction, right? But when you get past 5 million now, right, the cost is actually greater than the benefit. The value, for example here, the value of that 6 millionth barrel, right, is about $70, but the total cost is about $85, right? And so you're actually consuming something that is worth less to you. You get $70 of benefit there, but the total cost of it's $85. Society does not want that. The total cost of society exceeds the benefit of the value. By how much? Well, this vertical distance. Cost is the red line here, the social cost curve, and the demand curve. The distance between the social cost curve and the demand curve, at any level, beyond 5 million barrels, that is the total decrease in social surplus that occurs, because of that transaction. That is the deadweight loss of that transaction. The total deadweight loss, therefore, for all these 2 million extra transactions, suboptimal inefficient transaction, is this triangle there, right? Because we have the social cost minus private value for all 2 million of those transactions. Now, hold on. Some people, right, and I took off half credit on this particular part, I think a half a point. Instead of shading this to the deadweight loss, shaded this area here. Remember the area that was the private surplus, that green area, and labeled that deadweight loss. Now, that of course is not the deadweight loss. That is the private surplus, right? Now, it turns out that, well, hey, but the areas are the same. Well, they happen to be the same in this example because the demand curve is perfectly linear and the supply curve is perfectly linear. If the supply curve or the demand curve had any curvature at all, was not perfectly straight line, these two areas would not be the same. So not only would you have shaded the wrong area, you would have shaded an area that wasn't even the same total area or total value, right? And so I did not give credit, or I think half credit, whatever, for those who shaded this triangle here, which is the private surplus, and labeled that deadweight loss, even though it was the same area, right? Because one, it only was the same area because these happen to be straight lines, right? In fact, I could argue that if there is even a small kink that you can't even see in the line, your answer is wrong, right? Any kink at all, any imperfection in the line, these two areas will not be the same. So they only are the same if they both happen to be perfectly straight lines, right? So that's the first reason. But second, the reason that it's not the correct answer is that just because it's the same right area, I didn't ask you to shade any area that indicates the total amount of deadweight loss. I asked you to shade the area that represents the deadweight loss, right? So in other words, if you had taken this triangle and you'd drawn it over here on the right or on the top or on the lower left, or just because you drew the right size triangle, right, a right shaped triangle, does not indicate that, does not sort of satisfy the requirement of the question, which was shade the area representing the deadweight loss. So, but that said, I did give half credit to those who shaded that area, because at the very least, they shaded close to the area, and an area that was, if these lines are perfectly linear and they are of the same magnitude. All right, now the next question is, so now that's a deadweight loss. So how do we get rid of it? And so then I asked you which of the following government policies could help internalize the externality, right? In other words, force the private actors to take into consideration the external cost of their actions and move the market outcome closer to the social optimum. Well, I said, well, what about a tax imposed on sellers of gasoline, a tax imposed on buyers, a subsidy paid to sellers, a subsidy paid to buyers of gasoline? Well, the first thing is, remember, when you tax something, you get less of it. When you subsidize it, you get more of it. Right? Well, would we want to subsidize gasoline sales or gasoline consumption? The answer is no, right? If it's a negative externality, we've got too much of it. We want to reduce. We want to move, the market outcome closer to the social optimum. We have got to reduce the amount of gasoline produced and consumed. So a subsidy would move in the opposite direction. So neither C nor D can be right. Now, a lot of people checked either A or B, figuring out. But again, I didn't write it here, but I said check any and all correct answers. Well, although we didn't, this particular chapter, which was chapter 10, I believe, in Externalities, right, did not go into detail about, a tax on sellers versus a tax on buyers, right? Remember back to chapter, there were two chapters on taxation, 6 and 8, right? But chapter 6 said, remember, it doesn't matter. Either whether you impose a tax on sellers or buyers, right? You impose the right magnitude of tax, whether you impose it on the sellers or buyers, you have to do the same thing. So which of the policies would move the market outcome closer to the social optimum? Either a tax on sellers or a tax on buyers. And because I said check any and all correct answers, right? To get full credit, you had to check both A and B. Right? Then the second part of that particular subsection was, what would be the optimal amount of such a tax or subsidy per barrel of gasoline, right? So the idea is, if we impose a tax on sellers or buyers of gasoline, what would be the optimal amount, dollars per barrel? Well, the answer is, remember, first of all, if it was a positive externality, we would want to subsidize it, right? And the optimal subsidy, we learned, was the external benefit, right? The external benefit per unit, right? But this is not a positive externality. It's a negative externality. Oh, oops. That's a typo. Let me fix that right now. That was the copy and paste problem. So, oops. So let me do that. For a negative externality, which we have here, the optimal tax in this case is going to be the external cost, right? We sort of said the idea is you want to internalize externality, you want people to factor in the external cost or benefit of their action. Therefore, you have to change their value or their cost by exactly the amount of the external cost. So the optimal tax would be to be exactly on a per unit basis $30 per barrel, because that is the external cost per unit, right? Graphically, if we go back to our graph, what that is saying that the optimal corrective tax is the distance between the social cost and the external and the private cost, right? The difference between the social cost curve and supply curve, which is $30, right? That is the optimal corrective tax. I then said, okay, if you do impose that optimal corrective tax, remember what happens. Remember back to chapter 6. When you impose a tax, if you impose a tax of this amount, right, what happens? Well, the quantity gets reduced when you impose a tax. By how much? Well, you move to the left. Remember, it doesn't matter whether you impose it on the buyers or the sellers. So what's going to happen is you move, when you impose a tax, you move the quantity that the market will produce to the left, right? How much do you move to the left? Well, it'll move to keep going to the left until the distance between the supply and the demand curve is exactly equal to the optimal, to the amount of the tax, right? That is the idea. Remember from chapter 6. Again, this wasn't specifically addressed in this context in chapter 10, but it's the same principle. This question 13, did require you to remember not just chapter 10 on externalities, but also back to chapter 6 and 8 on taxation. All right, so if you impose that tax, then I asked you, okay, well, then with that tax in place, what does each buyer actually end up paying? And that would, by the way, with the tax of $30, that would, in fact, reduce the market quantity from 7 million to 5 million, because that is where the distance between demand curve and the supply curve was exactly equal to $30, which is the external cost. So the market quantity with the tax would be the optimum quantity of 5 million barrels, right? But with that tax, I then said, well, how much would each buyer pay total per barrel? How much, after tax would each seller receive per barrel? Well, again, we just find, remember from chapter 6, you find out where at that quantity, where it intersects the demand curve. That's the price buyers pay, P sub B. So each buyer would pay $80 per barrel, right? And each seller would receive $50. The price P sub C, the price the seller received would be $50 per barrel. And the difference, 80 minus 50, is of course the tax per unit. Right? Some people on this one gave answers of they were actually asking something that I didn't ask, though it showed some knowledge, but yet sorry I couldn't give you credit, was they, instead of putting the buyers pay $80, because I did ask what is the total that each buyer would pay per barrel, including any tax, if any, right? Well, and that is $80, right? But some people wrote 20 because buyers they were paying under the market, free market, they were paying $60 per barrel. Now they're paying $80 per barrel. So they would write 20, and for sellers they would write 10 because sellers were receiving $60 per barrel, and now are receiving $50 per barrel, right? Well, that is the incidence. Remember, tax incidence. How much of the tax, this $30 per barrel tax, is the buyer paying and the seller paying? Well, each buyer is paying $20 of the $30 tax. Each seller is in effect, paying $10 of the $30 tax, whether it's imposed on buyers or sellers. But that wasn't the question I asked. I asked you what was the price that buyers would actually pay with the tax, what's the price sellers would actually receive, after any tax, and so those are the correct answers there. And then lastly on this, I asked about tax revenue, right? What would be the total revenue from that tax? Well, again, this is just going back to chapter 8 in this case with tax revenue, right? Well, revenue is always price times quantity. Well, price and quantity in this case, so price is the price, if you will, is the tax per unit, right? And the quantity is the total quantity of barrels of gasoline sold. Well, under this tax, the total sold is 5 million, right? And so, again, the total tax revenue, just like we did in chapter 8, right? Remember shading this area here, right? It is this rectangle represents it. It is the vertical, the height of this rectangle is $30. That's the tax per unit, right? Per barrel, right? And the total quantity of barrels sold after the tax is 5 million barrels, and so that's the total revenue. 5 million times $30, so what? 15 million is the total tax revenue. Right? And so it's important to understand, and I didn't ask this, but think about this. So what happens is, right, that if you impose this tax, you get this yellow area for tax revenue. The output goes from 7 to 5. This deadweight loss goes away, right? It's not the case. People might think, well, wait a minute, so now there's this deadweight loss like we had. No. Because you almost want to ignore this, this part of the pocket, but there's no deadweight loss at that optimal quantity of 5, right? And the producer surplus now would be, for example, this triangle down. Well, actually, let me first do consumer surplus. It's easier. Consumer surplus would be, of course, the demand curve down to the price up to the quantity. So if this line continued, this triangle up here would be the consumer surplus after the tax on gasoline. Again, I didn't ask this question in the exam, but if you were curious, this would be the consumer surplus. What about producer surplus? Well, you could actually look at it two ways, right? It would be just not to confuse it with the tax revenue drawn here, I would have probably shaded this area here as a producer surplus, right? They receive $50 per barrel, right? And they sell this many barrels, 5 million barrels, and so it's the area above the supply curve, below the price, up to the quantity. So this is technically the producer surplus. It also happens because of and this is not independent of the shape of the curve, but because the social cost curve is exactly $30 higher at every quantity, right? The area here, if you looked at this part of the tax revenue here, if I extended this, red line out to the axis, right? This triangle here, below 80, above the social cost curve, out to a quantity of 5, would also would be the same amount as a producer surplus. Again, it's not necessarily accurate to say that's producer surplus because this is a better representation. Although I probably wouldn't have taken off if I had asked that. But again, the idea is understand that what happens is here we have like our old chapter 8 diagrams. We have consumer surplus up here, tax revenue, producer surplus. When the market had no externality, this area here was a deadweight loss. But in fact, by moving from here to here, we're eliminating the deadweight loss that was created by those transactions. There's no deadweight loss in that outcome. So Again, more information than you needed to answer this question, but like I said, it's my last chance to teach you any microeconomics. I have a captive audience if you're watching this, but that is the answer, how you answer question 13. So again, midterm exam on microeconomics, you all did very, very well. Those are the only two questions that seem to stump a fair number of people, and I hope that was helpful to those of you who were looking for answers. Thank you.